Term-to-term rules with Adam Maths Tutor. Here are the beginner questions, some of the easier questions that you're likely to see on this topic. First, we need to explain the rule for finding the next term in each of the sequences. For the first sequence, you can see it increases by the same value. We can add 2 to get from one term to the next. Always check at least 3 differences to make sure you've spotted the correct pattern. When it increases or decreases by the same value, we call this the common difference. This will help us with the type of sequence, since those with a common difference are linear sequences, which can or will often be referred to as arithmetic sequences. And using our term-to-term rule of 2, we can find the next 3 terms by adding 2 to 9 to give me 11, adding 2 to give me 13, and adding 2 again to give me 15. For the next question, you can see that there is no common difference. In fact, we are multiplying by the same value to get from one term to the next, and we call this a common ratio. In this case, the common ratio is 3, since we're multiplying by 3 to get from each term to the next. So the term-to-term rule would be described as multiplying by 3. These types of sequences where you multiply by a common ratio are geometric sequences, and the next 3 terms would be 108 multiplied by 3, 324, multiply this by 3, 972, and finally multiplying this by 3, 2916. For the third question, it may be more recognizable to see that we're dividing by 2 or halving to get from one term to the next. This is in fact a geometric sequence, and when writing the term-to-term rule, we need to do it by explaining how we multiply to get from one term to the next, and dividing by 2 is the same as multiplying by a half. The next 3 terms would be 24 divided by 2, or 24 multiplied by a half, which is 12. Half of this is 6, and half of this is 3. For the fourth question, we can see that there's a common difference. We're taking away 4 each time, so the term-to-term rule would be subtracting 4. This is a linear or an arithmetic sequence, and the next 3 terms would be negative 16, negative 20, and negative 24. For the next question, again, we may recognize that we're dividing by 4 to get from one term to the next, but dividing are in fact geometric, and we need to describe the term-to-term rule as a multiplication. So dividing by 4 each time is the same as multiplying by 1/4. 1/4 divided by 4 is 1 over 16. 1 over 16 divided by 4 is 1 over 64. And 1 over 64 divided by 4 is 1 over 256. For the last question, tricky, but it does appear as though we are doubling as we go from each term to the next. But we're also changing sign, which means that we must be multiplying by negative 2 each time. So the term-to-term rule is timesing by negative 2. Again, a geometric sequence. Timesing 8 by 2 and changing the sign to a positive would be 16. 16 times 2 is 32 and change the sign to a negative. 32 times 2 is 64 and change the sign to a positive. On to the intermediate questions with a slight increase in difficulty. We need to find the next 3 terms of the sequences. Notice that when we check the first difference, we can see that it's increasing by 1, and then by 2, by 3, and by 4. So it's not a linear or arithmetic sequence, and we're not multiplying to get from one term to the next, so it's not geometric. After you've checked those 2 possibilities, you then have to find the second difference, which is the difference between your differences. If this is constant, which in this case it is, our differences are going up by 1 each term. A constant second difference means that we're dealing with quadratic sequences. Therefore, I know my second difference will remain constant. So to find the next 3 terms, I'll need to increase the first difference by 1 each time. So adding 5 onto 13 gives me 18. Adding 6 will give me 24. And adding 7 will give me 31. For the second question, I have a similar situation where the sequence is going down by 2, by 3, by 4, and by 5. So the first difference is not the same, but checking the second difference, I can see that this is constant, so I can find the next term by subtracting 6 to give me 0. then taking away 7 to give me negative 7, and then taking away 8 to give me negative 15. For the last question, the sequence is a Fibonacci type sequence. Find the next 3 terms in the sequence. You can find the next term of a Fibonacci sequence or a Fibonacci type sequence by adding the 2 previous terms together. So the first 2 terms of 2 and 2 are adding to give me the next term, which is 4. To find the next term, I'll add the 2 previous ones, 2 and 4 together, to give me 6. We can check the last one to see that 4 and 6 are adding to give me 10. So to find the next term, I'll add 6 and 10 together to give me 16. Adding 10 and 16 together gives me 26. And then finally, to find the third next term, 16 and 26 will add together to give me 42. So the next 3 terms are 16, 26 and 42. On to the advanced question, one of the trickier questions that you're likely to find on this topic. The rule for finding the next term in a sequence is multiply the previous term by 3 and then add on x. They have given us a starting point. They've told us that the first term is 2. Using the rule, multiplying the previous term by 3 and adding on x, I can form an expression for the second term. So multiplying the first term by 3 would be 3 times 2, and then I'm adding on x. Simplifying this will give me 6 plus x. I can continue to find an expression for the third term. So multiplying the previous term by 3 would be 3 lots of 6 plus x, and then add x. Simplifying this will give me 18 plus 3x plus x, which simplifies to 4x. And lastly, if I go up to the fourth term, where I have 3 lots of 18 plus 4x plus x, this will simplify to give me 54 plus 13x. Now I can stop at the fourth term because they've told me that the fourth term is actually equal to 119. I have an algebraic expression which represents the fourth term in terms of x, 54 plus 13x. Now that they've told me the numerical value of this, 119, I can make these two things equal to each other and solve to find x. Subtracting 54 from both sides will give me 13x, which is 65, and dividing by 13 on both sides will give me x, which is 5. Here's a question that I've completed earlier. It appears as though I've made a mistake. Pause the video. Let's see if you can find it and write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.